Is it started? Yeah, it started. Okay. So can you see the screen? If yes, give me a big thumbs. Can you see the screen clearly? Okay, great. Okay, so let's move on. Okay, so normally when we start development, when we start create an embedded system design, this is a very fundamental way. So normally we just, oh, okay, I want to light up an LED, or I want to do a robot. You know, the robot can turn left and right. Write the source code, compile, simulate. You've got error. Simulate and debug it. You've got error. So finally, if you've got error, then you keep on repeat this process again and again and again. Then download the thing to the target processor, test it, and finally everything works correctly, submit. Okay, so this is the conventional way. It's not conventional way until today. It's still, people still practice, still using this. Okay, and it's used by a lot of hobbies. Like for example, I showed you last week, when they come to design, just design, come up with an idea. Okay, you propose, let's say FIP, you propose to your supervisor, you want to do this, then you start building your component, choose hardware, whether it's using Arduino Uno microchip or using a ESP32. Okay, then you test the hardware, then you do a coding, then you do a debugging. So the process is keep on repeating. Okay, so if you want to go more details, actually, it divided into two sections, the software section and the hardware section. Okay, let's say the user requirement. User requirement means you meet the customer, or you already have your own title, let's say FIP. Okay, then you start your system requirement analysis. Okay, so based on the requirement that given to you, you start doing analysis. Okay, what should you do? What shouldn't you do? Okay, what kind of microcontroller to choose, what kind of software you're going to choose. Okay, then only you do divide into two sections. They perform a system partitioning. You do a software and hardware specification. Okay, then do a technology survey. What kind of software is suitable for you, what kind of hardware is suitable for you, and these two is keep on communicate with one another. So remember, when you are in industry, you're not doing everything unless you are in a tiny, small company. So normally in a medium size or a big company, you divide it into the few department or few section, and you keep communicate one another. A lot of meetings is going on. So once everything done, then only you do a system integration and do a system performance validations. Okay, but actually, to the most difficult part actually is the first section, where defining the system architecture. Let's move on with this. Okay, so creating the architecture is something is not easy. So defining the system and its architecture, if done correctly, is the phase of a development that is most difficult and most important in the entire development cycle. For example, like FYP. So if you yourself propose a title, and the title is very vague, so you don't know where to start. Even though I propose a title, so I ask you go and explore, you face a lot of difficulty. Why? Because you don't know what kind of architecture you're going to use, what kind of microcontroller you use. Are you going to use ESP32? Are you going to use the MCS51 family microcontroller, or etc.? Or some of you involved in the integrated product design. So you, of course, you go and find something that is you familiar with. Let's say Arduino Uno. Oh, it's very easy. It's time to market. It's a lot of library for all of you. So then you just simply pick up this as your architecture, and you never know whether it's at the right right step or not. Okay. So this figure is very, very important. So this model is what we call that embedded system design and development life cycle model, and is used in a lot of company out there. Most of the embedded company is adapting this architecture. So let's move on. So the phase one is the toughest, which I told you. So phase one is creating the architecture. So this is the process, planning. It's just a planning design of the embedded system design. Remember, during these steps, look at this, I black in color, I just move on first. Okay, just open this up. Okay, so before we move to the second phase, okay, hold on. Okay. Okay. So this model also indicate that the most important time is spent in phase one. See this, you see or not? There's a lot of steps over here. So creating the architecture. So at this phase, no board is touched, no hardware, no software is coded. So it's just like in your FYP1, no one asks you to immediately start coding. You're asked to explore. You're asked to find journal. You're asked to do a lot of reading. You're asked to identify different type of algorithm. So basically, again, at this phase, no board is touched, no software is coded. It is about putting full attention and concentration and investigation skill into gathering information about the device that you're going to develop. Identify your enemy, your competitor. Okay, like for example, when Intel want to come out with their low power processor, they've tried to understand their competitor, which is ARM. So this process also, you want to understand what option exists and documenting those findings. So it's same like FYP1. You write down all your research, literature review, understand the problem statement. The problem statement lead you to objective. And all these things, lead you to the literature review, then only come to the methodology. Okay, so if anything wrong, this is keep on going in up. Means it keep on coming back, to decide which is the best option. Okay, so at this phase, I told you no board is touching. So if the right preparation is done, in this when defining this architecture, okay, determining the requirements, understand the risks and etc. Blah blah blah. Then the remaining phase of developing, remaining phase 2, 3, 4 will become much simpler, faster, and probably will be cheaper. Just like for example, if for FYP1 all your foundation work, you do it very well, then you move to FYP2, it will be much easier. Okay, and same, when you're moving forward, once you are your fundamental is strong in FYP1, FYP2, when you move to your master and PhD, will be much easier. Okay, so this is of course, the engineers responsible have the necessary skill. So if you don't have the skill, so you come back to square one. Okay, let's say you have come up with very good architecture, then the fellow, the engineer who write the coding are weak. This is also another problem. So in short, if phase 1 is done correctly, then less time will be wasted on deciphering the code. Then that doesn't meet the system requirement or guessing what the designer intention were. Okay, which most often result in more bugs and more works. Okay, we don't want this to happen. So this stage, you keep on discuss with the customer, discuss with the company manager. Okay, so remember this phase is very, very important. So once this phase is done, okay, remember one more thing. Phase 1 also include architecture business cycle. You must understand the market. Like for example, what is ISO 14,000 environmental friendly? What is ISO 9000, 9001, and 9002? All these things. What is TQM? All these things you need to understand. Like for example, you want to develop a electronic toothbrush. Okay, so in Malaysia is a halal country. If the blister of the toothbrush is made from non-halal material, you are in big trouble. So a lot of things you need to get the halal certificate. For example, if you're in Malaysia, you want to penetrate to the Muslim market, for example. So a lot of things need to be done, in the phase 1. So once phase 2 is much easy, is where the process of testing an embedded system and solving the problem means you're writing your code, you're writing all the, phase 2 basically is implementing the architecture. So the process of developing the embedded system, okay, code writing, hardware construction is much easier, okay, development system. So they got error, coming back. Then finally, the third phase is a testing the system, the process of testing an embedded system for problem and solving those problems that you encounter in the hardware and software when the integration between hardware and software is successfully being done. Okay, it's a testing stage. So finally, it's maintaining the system. So you do a lot of documentation, a lot of commands, and a lot of how you develop this hardware and software, all the schematic diagram, you make sure it's properly documented. It's just like you're writing your final year reports, or you're just like writing a final thesis, to show that what have you done, how you maintain it. Okay, this one is also very important for a newcomer, joining the company to continue your project. Okay, so this basically the development life cycle, of embedded system design. So this is a very important thing. Okay. So when you come to development tools, let's say for example, develop a system, there are so many development tools that you can use. Okay, when after you define a specification, let's say the specification is done, the architecture is being predefined, then you have a system design. System design you drawing a flow chart, you can using a block diagram, okay, and you can writing your pseudocode. Okay, so for student don't do this step one. Okay, write coding. From a coding, they convert into the flow chart or block diagram. Am I right? If right, give me a thumbs up. Okay, is it true? Yeah, I want to see some thumbs there. You're writing your code first. If the lecturer or someone asks you to write the flow chart, then the flow chart is coming in. Class, you did the correct things. Because normally in university, your code is very short. Okay, I don't think so. It's more than 1,000,000 lines long. So, but however, if you got 1,000,000 lines long code and you divide into 20 teams, 20 partners, okay, around the globe, so flowchart is very important. Okay, so flowchart, pseudocode, block diagram is very important. Okay, you wouldn't appreciate these steps, because until today, your code is mini, very short. Moreover, you keep on calling different type of library. Okay, so then when you come to coding, you can using Ultra Edit. If you don't have like microchip MPLAB, then you can using Ultra Edit, CodeWrite, all these things to do your code editing. Okay, or IDE, just for some of the information. If the website is over, you can have a look. But nowadays, the most popular one is the Git and GitHub. Okay, so Git basically is the one you install into your PC. It's you yourself doing a version changing, okay, to your PC. However, when the GitHub is the one you go on the cloud, on the cloud. Okay, so every developer can collaborate. Okay, let's say for example, let's say the integrated product design. You are in Penang, someone in Sarawak, okay, someone in Sabah, so they still can collaborate. Okay, because you are all allowed to make the changes to your code, so you can update. You can do a lot of things in the GitHub. Okay, so you can explore these two, Git and GitHub. Okay, it's very popular nowadays. So every time you want code, people ask you to go to GitHub or download it. Correct or not? Am I right? So then you doing compiler. You got GCC compiler. I pick 18 or 24. We got XC8 or XC16 compiler. Even though you got C compiler, you're using Eclipse. Okay, all these things are MDK. Okay, it's a compiler. So debugging as well. You got MDK and GCC and Eclipse for programmer. Then finally, you got do a system validation. So GitHub also allow you to do a validation. And of course, if you got microchip, you can using the debugger, to do it system validation. So a simulator to do a system validation. So this is for bug tracking. So you can download Buzilla, all these things, all the tools that are available in the market. Okay, let's move on. Okay, so this is a summary. I just move on. So here are some of the example of the equipments that is quite interesting, from small scale to very interesting big scale. Okay, like for example, pacemaker. Whenever, let's say for example, I decide to start my company, I want to design pacemaker. So of course, so this thing is very important. Correct or not? Creating the architecture. So before you creating architecture, always ask yourself this question. Always ask yourself this question. What is the processing power, memory, number of unit? If you say, I just produce one unit, what's the point, you doing this, start up this company, am I right? If you're able to produce billions unit, okay, very good. Like COVID-19 vaccine, okay, you create a lot of things, you know, like for example, glove is very important, okay, then the number of units is very high. That's why the cost is quite low, you know, it's cheap. So ask yourself all these questions. Pacemaker, some temperature measurement, like so 4-bit microprocessor will do. You're not going to use ESP32 inside these tiny mini things, correct or not? Okay, like handphone, you know, can't see, this is a Samsung S9, if not mistaken. Okay, so why I put on all these things over here? So all the handphone nowadays, like Samsung, iPhone, you know, everything, you just name it, they are not alone. Okay, they are not alone. Like example, like Maxim is from US, Avago, Murata, all these company, you know, like is from Japan, you know. So Broadcom from US, correct? Still remember is the CEO is our Penang guy, okay, Tan Hock Eng, correct or not? So all these things, you know, is scattered around. Okay, where is Samsung? Samsung just developed their own, probably their own microprocessor, okay, and probably some of other devices like camera. Okay, remember, you are not alone. Okay, just move on. So always ask yourself, even you create an iPhone X, iPhone 10, you know, you ask yourself all these questions. Okay, same with the iPhone. You see, Wi-Fi, they're using Murata. Murata is a Japan company, so they are, okay, just to let you know. Okay, like Sony, okay, it's from Sony as well. So just move on. Some of the okay, even Huawei. That's the reason, you know, Huawei nowadays they claim to be in big trouble. They need to source, you know, from other country, you know, because US ban, you know, give order to a semiconductor company not to provide IP, you know, to Huawei. For information, there's a lot of IP holded by a lot of US company. Huawei actually basically, I believe, in big trouble unless some of the other country that is willing to supply, you know, all this information to Huawei lah. So you see all these component, you know, we need to rely on everything. So this means that even though you are doing an FIP project, even though you're doing a master, it's perfectly all right. You are using other people code, okay, other people works, and as long as you cited them, give them a compliment, okay, at the end you just noted, oh, this is from which journal, you know, or which section I copy copy of the code from, you know, from which part, you know, which section you copy the code from, okay, from who, okay. So this is very important, okay. So wireless vending machine, okay, and dishwasher, even NASA sending the rover, okay, okay, they're using a VxWorks operating system. So do you remember, for information, that time when they're sending a rover to the Mars, and the rover malfunction in the Mars, they create such a big problem, big news, you know, in the early 90s, if I'm not mistaken. You know, everyone talk about that because their real-time operating system create some bugs, some problem. We'll discuss these bugs, you know, when it comes to the real-time operating system section, and we discuss about this this Land Rover. This is 2003. Okay, PlayStation 2 and 3. Okay, and some of the research currently going on, you know, highway system, you know, how to manage the traffic in Kuala Lumpur, for example. Okay, now because due to the big data analysis coming in, Adidas also put some electronic into the shoes to understand how the consumer running, all these things, you know, collect their data. Okay, so and of course nowadays quite popular is robot. Okay, now some of the microprocessor is putting into your human body, and it's happening. You know, those days it's just a movie. Nowadays it's really coming up. Okay, in the industry world. Okay, so car as well. There's a lot of changes in car technology. From analog, it's become mostly digital. Okay, start from year 2000. So remember, the communication skill that used by car CAN bus. Okay, we will talk about this later in one of the chapter as well. Okay, so please go through this website, scoff.com. So every year, this is a assignment that I given to your senior and to you as well. So you same as this year, you're going to develop a temperature, or you can develop some system for a animal farm. Okay, whether it's a chicken, pig, cow, anything. Okay, so we can go through this. We'll discuss this further in our lab section, during the lab section. Okay, let's look at this. Actually, this slide I putting in 2016. So at that time, nobody care about IoT, even Utah itself. So I thought about IoT, they ignore me. Okay, so you see whatever happened in US 4 years ago, this year is 2020. No, in 2016, okay, for information, this top 10 invention that really changed the market, in Malaysia nowadays. So whatever happened 4 years ago in US, in Europe, it will come over to Malaysia. Okay, example, Internet of Things. Okay, everyone know what is Internet of Things. Just for your information, IoT actually is nothing new. Okay, instead, in 2012, I already proposed a title, for my student on control devices, through Internet IoT. And that time, I'm not joking, just for information, paper is published. You can have a look at this paper. Okay, where's my thing here? Paper is published. You can go to this website. Okay, it's 2012. We went for a conference. Okay, so that time we are using the ENC 28J60. It's a TCP/IP stack. Okay, we communicate with PIC24, and we can control almost everything. Okay, even though we can link, even though we can control things through Facebook. Okay, we make it successfully. You can go through this journal. Okay, and it happened in 2012 for information. Okay, but at that time in Malaysia, people say that is a dream, for information. So I want to introduce TCP/IP in more details. Then they say, oh, this is for software engineering. Okay, but anyway, so please have a look of this journal if you got time. Okay, it's a very interesting. Even nowadays, it's still interesting. We can adapt it into our IoT system. Okay, let's come back to this. Okay, so then the rollout of development board. Okay, nowadays, of course, you can see that different type of development board. So the creation and development board actually is speed up the time to market. Okay, like Raspberry Pi, Arduino, BeagleBone, all these things. Okay, then the ARM architecture also evolving to ARM 11. So different kind of ARM architecture, you can have a look. So it's, for information, is popular in 2016. It's still popular in coming 10 years for information. Security is come into the play because of everything is IoT. Use of Linux, please go and download Linux, download a virtual machine, install Ubuntu, Red Hat, familiarize with Linux, because it's very important. For information, all your Android phone, the kernel, they are using a Linux kernel. Okay, just to share with you. So consumer electronic and medical electronics. So medical is something that is very, very important. Everyone is worried. Everyone want to have a long life. Okay, if you're rich, you're going to buy organic food. Same in the medical industry. If you're rich, you want to buy a lot of gadget, to make your life longer. Okay, so automating back-end tools. Okay, back-end tools is very important. Okay, like for example, all the compiler and debugger is a back-end tool. As for information, compiling and debugging is something is very tedious and very time-consuming. Okay, so that's why they come up with a proper and more advanced, debugging tools. Okay, use of digital power. As for information, a lot of traditional analog versions, is being replaced by digital power. So it's good to understand all the digital devices in the market. Okay, so of course, electronics, automobile. You can see that nowadays, even our new Proton car, switch open. I mean, open the window. I also don't know what's the reason, you know, because you just need a window, but you still want to have features like switch on. I don't know, switch on the light, open the window. Okay, but this is I don't know what is the reason you want this. Can you just send me a message? Okay, why you need to have you near the window and you still need to voice up, open the window. Okay, Proton, open the window. I don't know. Okay, so then you got 3D printing. 3D printing is something is happening, you know, in 2016, become a lot of popular nowadays. Okay, okay. Just to share with you, yesterday I accidentally went to this website. Okay, it's still running. Okay, it's a medical product. Okay, it's a brain wet simulator. And the price is quite cheap, it's 300 plus. So you see, when you come to design, you must understand the market. So they're not, a lot of people, because a lot of you guys, I mean, you as a student, you are very stressed, all right? Your sleep is not good. So it's that this device can calm you down. I'm not promoting this device, okay? Remember this, I just let you see how the things is going on, you know? Okay, so they are in prototyping now. They're in production. Okay, to sell it, you know, in the secret price is 339, free shipping. Is started in Japan, mass production in China. Okay, you can have a look. Okay, let's have a look. Okay, so all this AI power, all these things, you know, marketing is involved inside there. Okay, so it's give you, this is a marketing. So this means that when you develop an embedded system design product, you need marketing. So they got stretch goal is just marketing. Okay, this is marketing. Okay, apps is marketing. Okay, then this is a problem statement. Whenever you do a FYP, whenever you do anything, you must understand what is the problem. And the problem statement is you can't sleep, you are stressed. Okay, so what is the solution? These are the objective. They are relax your mind, goodbye to stress. Okay, chronic illness. I don't know how well is this. Nobody know. So he said that, oh, they create a lot of this simulation, you know, let you look, wow, okay, see, they do a lot of simulation here, a lot of research being studied. Okay, so then a lot of research paper is being published. So yeah, you as a consumer, you have to go through all these research paper. So all these things, you know, I also don't know what is that. Okay, whether it's really work or not. They claim they already have 100 beta user and counting. So just 100 the whole world, I'm not sure. So this is how effective is that. They come up with a graph of these 100 people, and the developer is over here. So, and this is marketing. Okay, so how it works, he show you, it's very simple. Just press the button, it release a low power, low frequency gamma, and can let you feel relaxed. Okay, and then they come with all these things. This is just marketing theorem. Okay, okay. So when it comes to embedded system design, you also need SolidWorks to draw your design. How nice is it? Okay, just like your IDP lah. Okay, so you draw it. You know how they are going through it. You know they say it being created. You know, the founder is a machine learning with a PhD, medical and human rhythm and mechanical engineering when he studied in Japan. So this means that you guys, as a student, you can come up with something fantastic, okay, with a proper, if you're confident, then you come out with a proper product, okay? Then just 2 years. I believe that he started his PhD in 2012, for example. So start from 2012 to 2018, then they come up with the idea 2020, okay? So then they're in production. Everything is happened in China or Hong Kong. Okay. So, and this is a co-founder. This is the PhD in medical. So you need a medical expert to help you because this is about sleep, okay, or psychology. So R&D engineer or medical expert. They need R&D engineer means they need electronics. You know, like this one need to do electronics. Do a lot of study. You know, on all these brand things. And this means that they already went through a lot of poster competitions. Still remember FYP, every year they got poster competition. A lot of people come and look at your design. Yeah, if your design is interesting, you get the credit. The company will invest into your design, just to share of you with all of you lah. So here are the timeline. A lot of study being done, and then yes, you can come up with their own things. I don't know how well it's going on, but so far it's not many investor, and people also complaining about their design. Okay, and so far they hit the target. They got 646. They got about 257,000. I don't know whether, I don't believe that this is a good figure for information. Okay, let's move on. Continue our study. Okay. So now we move on to the survey. So class, the full survey is already given to you. So remember, survey is very, very important. Okay, why survey is important? Survey is determined whether you are at the right pace. Are we at the right steps? In studying embedded system design, in studying all the tools that is existed in the market. Okay, let's look at the survey. Okay, and survey also lead you 5 to 10 years in future. Okay, so this study is done mostly by Americans. Okay, but however, you look at the figure from 2017 to 2019. 2019 is until March. Okay, this is just done until March. You can see there's an increase of participants from EMEA. EMEA is Europe, Middle East, and Africa. And Asia Pacific, China, Malaysia, Singapore is increased drastically. So this means that the Asia market, a lot of participants from Asia as well. Okay, it's increasing start from year 2017. Okay, so most of them are class. This is about few hundred pages of research a survey. So I just take out something that is interesting. So most of them, the job function is about hardware and software integration. Okay, so this means that hardware and software market is big. So if you're good in hardware and software, debugging, all these things, this is what is really needed in the market. So writing firmware and software actually is in demand, 51%. If you're good in firmware writing, I can give you a job, in Singapore. I got a lot of your senior and a lot of my friends is asking whether they're good firmware, how write a proper firmware, know how to write a firmware. Okay, so and based on this result, you can see that I don't know why Asia Pacific come out from a school is 21.9 years old. How old are you guys? You see that Asia is a bit kiasu compared to America, 28.3 years old. Okay, let's see what is your comment. Okay, how do we pattern something? There's questions, from the floor. How do we pattern something? So patterning needs a lot of money. Okay, so they need to go through a long process. Okay, if you want to know, I will let you know, because it's a long process. You need a company to sponsor you, give you some money to move on with the patterning. Of course, Utah also agree, to involve into this if you got a nice patent. Okay, so patenting is something that is very subjective. So you see in the US market, you see in Asia market, sometimes you patent in US, probably China also can copy. You see a lot of complication down there. You need to get a lawyer to find out. 22, so young. So actually, it's the right time lah. Next year you're 23, ngam lah. Asia Pacific means you graduated, you go out to work, So means Americans enjoy life first. They know that they will need to work until 65 years old. They enjoy a few more years. Probably they are study PhD or master, I'm not sure. So this means that in Europe as well, it's 23.2, I'm not sure. Okay, let's move on. So when you involve in the hardware and software, mostly is the industrial control and automation. Malaysia, a lot of industry, a lot of automation. Then they come to consumer electronic. Internet of Things is growing. It's definitely is moving up. Okay, I think this rank is moving up soon. Okay. So how important is IoT? So most of them say it's important. Okay. So when it comes to IoT, everyone is moving into the sensor base because IoT need a lot of sensor ma. So industry, sensor, and cloud. Okay, and smartphone is over here. So it's going up. Remember, 2019 is just until March. Okay. So when it comes to IoT, they are talking about edge. Okay, IoT edge device. Okay, so this is something is quite popular nowadays. Then wearable devices is also quite popular. Okay, so this is the thing that they are summarized, based on the first few slides. Okay, considering application of which you are aware, what do you regard as the most interesting use of IoT? So actually, it's automatic traffic control and blah blah blah. You can have a look. Okay, based on this, this output, you can move towards to this. Then means you can get a proper place in the market in future if you want to continue as an IoT engineer. Okay, like for example, medical, drone. You see, all these things is happening, in the world. Nowadays. Okay. So, and then you look at, this is in 2015, you look at what happened in 2015. At that time, look at this loop. Okay. So this is the booming time, peak. Machine learning, everyone talk about machine learning in 2015, augmented reality, virtual reality is here, stop at enlightenment. This one is say is illusion. Okay. So all these things is going up. I can have a look, So these are the peak. Even in 2018, deep learning is in the peak. Okay. So IoT platform is also in the peak. Okay. So this go through this so that you can prepare, like quantum computing, all this 5G is moving up, innovation is triggered. Like all these things is triggered in the innovation, 4D printing, is triggered, is going up, Okay. These are the peak. How long this peak will last? 5 years, 10 years, nobody know. Okay. See, now, of course, deep learning is such a big thing nowadays. Okay. So when you talk about advanced technology, which one is the most important? Actually, is embedded vision, image processing. Okay. So if you put in image processing, you are looking forward to the embedded vision. Okay. So hardware, are you implementing in the current design? So you're using a microcontroller security features, most of them into the security features. So this is the advice for you. Please focus on IoT, AI, all these things. Okay. So number out of school is 26.3. So job function is mostly on hardware and software. So you can go through this. I'm not going through this in details. Okay, let's move on. So real-time operating system is important. Okay, when it comes to nowadays, Wi-Fi is a lot of people using Wi-Fi because nowadays, especially in this COVID-19. Okay, so then Bluetooth low energy is booming up. It's very popular, and followed by Bluetooth and so on. Okay, so still Bluetooth low energy mesh is very important in your embedded design. Then followed by Zigbee, all these things are. So, and then out of all the development board, which one is most popular is STM microelectronics. Let's have a look of the board of STM microelectronics. What's the time now? Let's have a short break, Okay? Is it okay? Let's have a short break. Okay, this is the very popular nuclear board, STM32. You see, I already attached the ESP8266 over here. This ESP8266, you see or not? So it's a stackable. Can you see? It's stackable. You can put a lot of board until here. Okay, until here. Okay, so it's stackable. Let's say, for example, you got Bluetooth board, you put here. Then on top of it, you can put another one, and another one, and another one. Okay, this is the nuclear board. Okay, nuclear board. Okay, I secure 6 pieces, you know, from STM. Is part in our lab now. Okay, few years back we are using this as a tool of teaching, but it's quite stressed for most of the students. They are complaining. Okay, they prefer microchip because they are used to microchip for microcontrol, microprocessor. So finally we decide to use this as FIP for FIP project. Okay, so those who are enrolling for my what I call that indoor navigation will utilize this board. It's very powerful. Okay. Okay, can we start? Or we want to have a break? If you want to have a break for a few more minutes, just type break. Is everyone back? So are you back? Okay, shall we move on? If yes, give me a thumbs up. Okay, so okay, you continue. So class, you can see that, you know, in the market, did you start your current embedded system with a development board? They say yes, and most of them prefer STM microelectronics, followed by Texas Instrument, NXP, Raspberry Pi because it's booming. Only it's come to microchip. Some are using Arduino. So microchip development board still got this market. Okay. Okay, and so on. Okay. So what is this? I also can't see. What is this? How many months did your project take to finish? So remember, most of the project given, you have to finish within 1 to 6 months. Not many is more than 1 year. If 1 year or more than 1 year, I don't know what kind of project is that. Okay. So then most of them are using C. So that's why C is still very important in the market. Okay, in embedded system design. Although MicroPython is coming in, still Python give a lot of, it's not as good as C because Python is slow compared to C. Okay, 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 remember this. And of course, assembly, not many, Java, MATLAB. Okay, so this is a low-level developer. So next time still using C, although Python is increasing. Okay, C and C++ still got this market. So for your information, the coming years, coming 10 years or 20 years, C and C++ still got this market. Don't worry. So it's very important. Okay. So and from this, you also realize that 88% reuse the code. Reuse the code, probably developed in-house. So this means that when you join a new company, you are seldom asked to write everything from scratch unless you open your own company. Okay, when you want to continue your senior code, so you need to understand how to read and understand other people's code. So this means that you need to have an skill, you know, of reading and understand others' code. Okay, let's say for example, last time when I in Intel, so a lot of code is developed in India because they say India is better than Malaysia. Malaysians are very bad in software development, okay, in coding. So, but the problem is Indian software developer are very bad in documentation. So when you're going up there, look at the code, it's big headache. It's functioning, but it's big headache. I'm not sure how many of you went to Intel for intern last year. So if yes, let me know. Is this the problem that you encounter in Intel? I believe that is still the same, until today. Okay. So this is the advice for you. Design capability, we prefer real time. Okay, 54%. Okay, so you can have a look lah. So C is still very important. You must learn how to reuse other people's code. Okay, everything is reused, even hardware or IP hardware. Okay, so when you come to embedded system design, which are the things that you always consider? Meeting schedule is a big problem. Debugging is a big problem. So these two things is a big problem lah. Okay, very challenging. Okay, you just move on to this thing, you can have a look. So if you want to improve in an embedded system activity, what would it be? They say it's an engineering team skill level. So it's not easy to work as a team, I believe that. Okay, especially those in Asia. You see, team skill level, he said need very important, 26.2. Why? Because Asia got one habit. They keep it to themselves. Okay, that is the habit for most of them. I don't know, Chinese. I'm not sure lah. That's what I feel. So team skill is very important. You work as a team. You are not lone ranger. Okay, then debugging tools is very important. You need a proper debugging tools. Okay, so this means that okay. So and how to improve, their knowledge. Normally they go to the website called Yi Times, Googling all these things. You can have a look. I believe most of you see Stack Overflow when you got problem in microchip, you type, sure you direct you in the Stack Overflow, they give you some solution, okay? IEEE, all these things are very important website, okay? So next year, what areas will be greatest technology challenges? So integrating a new technology. Let's say, for example, if you're using, you're not an IoT user, suddenly a company move to IoT, new tools is very challenging because the company don't have this expertise. Let's say most of the company in Malaysia, especially nowadays, everyone, is still stuck in industry 2.0. Some is just industry 3.0. Okay, so when you migrate to the new technology, it's not easy because most of the old engineer is still there. So you ask them to resign, no. So it's not easy, okay, to migrate to the new technology. So and then this is all the problem they are encountering lah. So in software design, debugging tools, oscilloscope still number 1, followed by debugger, compiler, and IDE. Okay, so in-circuit emulator is expensive. JTAG, PDM is a proprietary for Motorola. And JTAG is a proprietary for Intel those days. So JTAG is already integrated in your PIC24 microcontroller. We'll go through this in details. Logic analyzer is too expensive. Okay. So how you maintain and educate your professional skill? Join webinar. So Utah give you a lot of webinar. Just join live training, ask question. Okay. So this is how they do it. But surprisingly, in Asia, they just technical reading average day per year spent on career training. No, Asia is I don't know lah. But it's increased of 4.5 at least in, is it Asian Pacific? 3.9. It's very bad. So you don't like to read. You just don't like everything lah in Asia Pacific. Okay, I don't know. Okay. So these are the challenges that are meeting schedule. Okay, tutorial 2 is still oscilloscope. Okay, so training, 8.1 days, in the career training, this is what that means. Okay, when it comes to real-time operating system, they still prefer without commercial support. They prefer their own developed operating system because commercial operating system is very, very expensive. Okay, so when talk about commercial operating system, they're light because they have a real-time capability and good software tools. Okay. So what are the reason of not using commercial? Of course, is is expensive. Of course, the current solution and the one that developed by themselves is sufficient. Of course, they don't want to move to the new to the commercial operating system. Okay, what are the most important factors choosing operating system? Full source code. So everyone wants full source code so that you can do a lot of modification. Okay, so support is also another very important things. Then it comes to the compatibility, software and system tools. Okay, the development tools are basically, so all these three things is very important. Okay, when it comes to operating system, which one is most popular is embedded Linux. Okay, why I don't put in Linux? Few years back, I put in Linux, students couldn't take it. Okay, because they're too familiar with Windows. Okay, when you talk about Linux, we talk about those prompt, dir, ms, ldr, all these things, command prompt, they can't remember, they can't accept it. So that's why we just remove embedded Linux. But it's good to know Linux is very important. Keep this in your mind. Okay, I already discussed with Dr. Lai. We try to integrate Linux in his Python class. Okay, in-house custom made is good. So third is FreeRTOS. We're going to use it. Still popular, 18% compared to 21%. Okay, so we're using FreeRTOS. Okay, it's free. Then follow Ubuntu class. Remember, the not free one, like Micro COS 2, is still hit the market. So this is the one. Micro COS 2 is still hit the market. Micro COS 3 is 4% in the market. It's quite big, Normally, Micro COS 2 and 3 is used in military, used in NASA. NASA not going to use this FreeRTOS. They're not going to use embedded Linux for information. Okay, they will prefer something, the paid version, like VxWorks. Okay, it's a paid version of a real-time operating system. Okay, so still in the coming 12 months, it's still popular. Okay, although means that Micro COS 2 is still popular, but they are going down. They prefer Micro COS 3 is a newer version of Micro COS. Why I'm using Micro COS 2? Because it's free. I can do a lot of modification, for education purpose. Okay, I already modified the Micro COS 2 to suit PIC 24. I will give it to you. Okay, then of course we'll look into the FreeRTOS as well. So here are the advice for all of you. So what class? This is very important because you are going out to industry soon. So these are the things that is needed, whether it's in Asia or whether it's in US. Okay. So come to processor. Of course, 32-bit is popular because of ESP32 is a 32-bit. It's 8-bit in the market. This is 16-bit. 64-bit is coming up. Okay, just for information, until 2019 is dropping, coming up. You see, so we just explore until 32-bit, which is ESP32. So the vendor that I prefer is still Texas, STM, and then only come to Microchip. Okay, so Microchip is still the top 3 in the market. Okay, so software development tool is most important, followed by chip performance when it comes to processor. So please select the vendor that you prefer. So for information, merge brand, because Microchip merge with ML Microsemi, it still take about 63% in the market. So means we are at the right choice. You see, in America, they prefer microchip, Atmel, Freescale, and TI. In Asia Pacific, they also prefer microchip and Atmel, like Singapore, they prefer microchip and Atmel. So you are at the right pace, okay, it's good, okay. So Big 24 still got his market, Big 18 still got his market, okay. So vendor you are currently using is still Atmel microchip now, okay. Atmel is those days is different now they are merged so it's still 40% in the market. So it means that you got your value okay. Microchip Singapore, the company is in microchip is in Thailand and in Singapore, not in Malaysia okay. Altera is already merged with Intel, so FPGA is also one of the very key important things nowadays. NXP as well, okay. So 32-bit is still STM32. Follow number second is a microchip SAM ARM architecture. They're all using ARM architecture, STM32, okay, and so on. So you can't see ESP32, okay, because this is for hobbies, mostly for hobbies, okay. So microchip, Texas Instruments, 16-bit. So means we are at the right place because we are learning Big 24. Great, okay. We are still learning something related with 16-bit, okay. The TI MSP 430 last time we used it again 5 years ago. I received 40 copies of development board on Texas Instrument. I introduced this in 2016. Students also couldn't accept this. They are stressed, I don't know why. When they come to use a new IDE, new platform, they can't because they are too familiar with microchip. For your information, I don't like microchip. Okay, even though they are #1 in the market, probably of their marketing. Okay, so of course, 8-bit microchip AVR, microchip is #1, so means your microcontroller, microprocessor, you're at the right place, but unfortunately, you are just using assembly program So same DSP is still in the market. Still microchip is #1 in the market. Okay, here is some of the vendor. So why is important? Once you know TI, Atmel, you're good, you master all these things, is beautify your CV. So it's easy for you to look for a job in future. Okay. So when FPGA is Xilinx, company in Singapore, Altera is Intel now merged. Okay. So simulation is still a key thing because a lot of companies don't want to spend. Simulate using simulator just like today. Early this morning we tried simulator. Okay. I think that's all for chapter 1. Any questions? Any questions in technology class? Remember, embedded system design, is not teaching you how to use microchip, how to use ESP32. Okay, for information, to use all these things is not difficult. The toughest is these 2 words, how innovative you are. I teach you, you are master in ESP32, but the question is, you use it for what? Ask yourself, you got a very advanced ESP32, you got very advanced big DSP, okay, you got very advanced Texas Instrument development board, but ask yourself, what is the purpose of getting all these tools? Yes, you know how to write, you're a very good programmer, you know how to write a fantastic code, but you ask yourself, in order for you to survive, okay, become popular, become famous, you ask yourself, is where you are heading to. Okay, so this is the questions. In the end, you just an assistant. Assistant. People give an idea. I want to do this. Oh, okay, I know IoT. I help you to continue the project. Okay, so the idea is still the very important. So who always gives the idea? US. US give a lot of idea and let Asian to continue their work. While Asian continue their work, US come up with another new idea. Okay, so that's the trend until today lah. Okay, so I think that's all for this chapter. So any questions you would like to ask? Any questions? Even this morning, you know, have you able to take all this your MPLab X working? Okay, I hope that you try, you know, watch the video again and try it during this weekend. Okay, it's very interesting because now you are still free. Okay, that's the purpose. I give you a lot of extra classes. Okay. So any more questions from the floor? Let's check. Okay, let's check. Let's come back over here. Dismiss questions. Okay. No question. Why all this unhappy, angry? Why angry? Why so angry? Go back this campaign. What is this? You got back this campaign? No lah, of course no. I found it is interesting because it's medical product. You also can come out something like that. You go through a lot of means you need to go through a lot of research. Remember, you know, like for example, I proposed the indoor navigations. You know, you see, first we start purely on algorithm, no hardware involved. Then slowly we go to hardware. Okay, it's just something like that. Okay. It takes a lot of courage, you know, to go back, you know, to the market, to the business. It's not easy because you know, just now this the brainwave is they are Japanese, because Japan is very expensive and the production line, the manufacturing is very expensive. That's why they move it to China to have this to manufacture. So when you have you ask China as a partner, you know lah, Chinese in China is very difficult to deal with. Okay, especially, you know, in the manufacturing line. Okay, you got time, I can share some experience with all of you guys lah. So any question? If no question, we move to another things. Are you already explode? Already tired? Let me check the attendance. 34. Let me download the attendance first. Okay, let's move on. Okay, we don't want to talk anything. Let's talk back, you know, why the hex code is so important. Why hex code is so important. Class, do you still remember? Tell me, how many of you used PickKit3 before to upload your code, you know, into your target processor? This is what you're going to do, correct? Last time you got the integrated programming environment. Still remember? When you download microchip, you can download the micro IDE, you can download the IPE. All right? Then you write your hex code. They're linked with your beautiful USB. And this is your PickKit. This is your PC. And then how? Then you link to your board. All right, your whiteboard. Your mouse controller is here. You link few pin. Okay, few pin. Correct. You link few pin. Am I right? If yes, give me a thumbs up. Or if you never used this before, tell me no. Still remember this? So how many of you got PickKit3 at home? Okay. The supplier, the big supplier, what's his name? Mr. Kong, you got PickKit3 at home? Mr. Kong, you have picket 3 at home, got 2. You're so a lot, so rich. Picket 4, you don't have picket 4 leh. Also got 2. Okay, anyway. So if you look at picket 3, you open up picket 3. Inside picket 3 is a big 18F4550, if I'm not mistaken. Okay, so one of the key objective of picket 3 is what? Is to getting all this code coming to here and pass it to, I change the color a bit. Let me change the color a bit. And pass it to all the code transmit over the USB, come to here and transmit, transmit all these things into your target processor. Let's say this is PIC 18 again. Okay, class. Picket 3 must have definitely need to have a firmware inside to do all this business. Okay, am I right? So one of it is to able to get all this hex code into the target processor. Still remember today we got a hex code, something like that. Let's say 20 0 0 0 0 0 0 1 2 3 4 and something like that. All right. So this is a hex code in another line. Okay. So remember, colon, can colon travel out from your USB? Question for all of you. How picket 3 to identify colon? Anyone? Got the screen, where is that? I'm not sharing the screen. You share what? Can you see this? How? Can you see the screen? If you can see the screen, give me a thumbs up. Who cannot see the screen? Why Nicholas cannot see the screen? Okay. Class. Okay. So. Okay, I repeat class. So a sequence of hex code is already generated. When you run the when you perform the compilations process. And remember, whatever coming out from here, from your PC to picket 3 is in ASCII code. So this means that when colon is coming out is 0x3A. So this means that what is coming out is like this. Travel out from a USB cable to the picket 3. Okay, followed by 2 again is in ASCII code. 0 again is in ASCII code. Okay, is it clear? When all these things reach the picket 3, the target processor PIC 18 F4550, the firmware that is written by you. Example, you are the developer, so he must able to decode. When you receive colon, when I receive 0x32, I able to decode this colon and going, to perform the necessary actions to PIC 18, your target processor. Example, I know colon, I know got 20, okay, all come in as ASCII code. You need to have a ASCII code to binary converter inside your target processor. Okay, do you catch it? Okay, so then we know that 0, 0, 0, 0, all this in ASCII code, you know that start from 0, 0, 0, 0, and this is still 0. I got 20, let's say 10, sorry, 10, 10 different type of data, 0, 0, 0, 1 until 0, 0, 0, F example. So you go inside, let's say 0, 0 content 49. So all these things you transmit, into the PIC18 microcontroller. So until the end, they perform a checksum, whether they got error in transmission or not. Okay, so remember checksum is the second complement. Each line perform one testing. Okay, and over here also got a loop, 10 times a loop in hexa, so that it can store all the data 12, to the address 00 to the target processor. Do you get what I mean or not? Of course, they got a USB driver inside the this PIC3 as well. They got other things also. So do you get what I mean or not? If you understand the structure of a hex code, basically you can write the firmware, firmware for the PIC3 programmer. Okay, how to program, the hex code into the target processor. Is it clear? Any question? Is it clear? Okay, and of course, I'm not asking you to write the code, okay, but at least you must understand the concept. So I repeat, I just repeat this section. It's a bit heavy. Okay, so these are the hex code. So I repeat. So basically, we got normally hex code is start from colon, okay, colon 10. Let's say 10 is the let's say I don't put 10. Let's say don't put 10. How to remove this? Colon, let's say 02, 0010. Okay, one line, two line, address 00 is the beginning of the line. Let's say go 1, 2, 3, 4, and checksum. So this means that basically it's just like address 0010 contained 1, 2, address 0011 content 3, 4. Okay, so this means that if all these thing is over here in your terminal, you transmit coming out through your USB cable or UART cable. Okay, start from a colon in ASCII code. Okay, let's say 0x3a is the ASCII of the colon. So you go to your PIC3. And the PIC3 itself have a microcontroller. Microcontroller have a firmware inside. The firmware able to convert this 0x3a, back to the colon to indicate is the new line. So then they know that they store. Let's say they store 02 example. Remember 02 is coming out as a 0x30, 0x32. So after decode, they know that I store X is 2 times, okay, Y is address 0010. So for example, X equal to 0, X less than 2, X plus plus, they're probably using a pointer to point this, store this into the address 0010 and pass to the target processor. So that the target processor will know that at the location 0010, I can store 1, 2. Okay, store in where? Store in the program code. Okay, so PIC3 is just a middleman to do all this transfer. Okay, so if you understand this concept, you're able to develop the PIC3. Of course, the market is very niche. You say not many people using PIC3. A lot of people using consumer product rather than PIC3. Yes, but you must remember firmware developer is not many people know how to write, so your salary is definitely is larger, is higher, than other engineer. Okay, just for your information, because the market is not very niche. Okay, so is it okay, class? If okay, give me a thumbs up. If okay, if not sure, please ask. Okay, please ask. Okay, I hope the concept is there. Okay, and then of course, each line at the end is a checksum. It's a checksum. Okay, it's a checksum. Okay, I tell already, 00 is the data record. Okay, 01 is the end of the file record. So that's when you see 01 at the end, this is 01, means that it's already end of the file. Okay, end of the file. Okay, so checksum is the final one. So basically your target, your firmware also able to do error checking. Okay, so he add all these things together. He add all these together, and perform a second complement like 01. 01 is this. Second complement is a +1. So it become FF. So this is FF. Okay, to check whether you understand, can you tell me what is this answer? Okay, come on, tell me what is this answer. What is this answer? Can use your calculator. I hope that you know how to use a calculator and how to use a second complement inside your calculator. What is the answer? Anyone? Give you some time to do some exercise. What is the answer? Come on, find it, get the answer for me. Yes? Anyone? Anyone? Yes? What is the answer? Can you try to work it out? This one. What is the answer here? Basically, just add all this together. What is the answer? Anyone from the floor? Okay, no one. B4. Okay, I don't know. Let's assume Wei Han say B4. Okay, I assume it's correct. So we just basically add all these things together. Okay, and then perform a second complement. So this means that over here, they're able to add all these things together and compare with the final value. If this is B4, means it's good to go. It's good to download, transfer this file to the target processor. If this is not the same, let's say, for example, your wire got problem, this one become 0. Okay, so if you do second complement, it's no longer equal to B4. So that's therefore it will return error. Error will display on your screen during the programming time. When you program a hex code into your target processor through the packet tree, if they got error in checksum, you pop on the screen say checksum error. Okay. Okay, it's okay. Let's come back to this. Okay, so there's a lot of languages in the market. We got C, we got C++, we got Java. Okay, so and I believe that you're already quite good in assembly language. Okay, so based on 2019, Python is a #1 language. So remember, #1 language for web, for enterprise. But actually, when it comes to embedded, it's not Python. So remember this. Okay. Okay. So when it come to embedded, C is still the #1 in the market. Remember this. Okay. And you can see from this chart, Java, because Java is quite similar to, I mean, actually it's actually Android. Okay. So in mobile communication, Java is hit the market. If you say for the mobile market, Java is a #1 language. But you say overall, yes, Python is a #1 language. Okay, because you can go web development as well. You can do enterprise, okay, programming, okay. And remember why people like Python, because it is a lot of library. First thing, it's easy, it's simple, it's fast, time to market. You want to fast to develop something, not the compiling fast. I mean the development. I want it very fast to reach the market. Time to market is very important. So that's we choose Python. If you want fast in compiling, when you're dealing with all the operating system, low level, all these things, embedded product, you still prefer C. Yes, Python is coming up. We got something called MicroPython. But remember, MicroPython is just a baby in the market. C is in the market for years. They are very well developed. Okay, just for your information and so on. So Shift is a iOS. For iOS, correct? Shift is iOS. Okay. Swift and Java. One is Android, one is iOS. Okay, so this is the timeline based on embedded.com. In 1990, okay, I think you're still a baby. Probably you're not even born yet. Okay, small type of microcontroller. Okay, so we always use assembly code. So all the PC-based, server-based, we are using C program. But in 2016, the story changed. Assembly is just for a mini microcontroller like PIC 12, PIC 16, for example. Okay. So then C programming is still in the market. So Python, I put this is a shaded area. It also used here sometime for a small, medium microcontroller. But people tend to think that it's being used here, okay, for Python, okay? Okay, is it all right? This is a timeline. So still Python is important. I didn't say it's not important because Python is easy. That's why people always use Python in deep learning, in machine learning, because it's straightforward. Like Python do not have pointer. Okay, C programming is tough. They got pointer. When you point here, point there, point here, point there, you also don't know where you are. So that's why it's important to understand pointer. I will introduce pointer, all these things to all of you. Okay. Do you still remember what is pointer? Yes or no? Just key in something, in the message. Just say yes or no. Pointer. Do you still remember pointer? The star, this one, pointer. Sometimes you can see arrow. Sometimes you see a dot, A dot B, example, the dot, product, pointer, the arrow. Okay. Have you ever see this? Okay, tell me. I put this A, B, and C. You can choose more than one. So which one you really see before, experience before? A, B, or C, or D? D is where? D. None. A and B. Oh, very good. Wow, Zheng Zheng, very good. Huh? Man Seng, how come you know dot product? You never see pointer and arrow. Strange. Using A and C. Okay, common. A and C is common a lot because the arrow, not many use arrow. Just two of you only. Others? Okay, doing Flutter. Okay, Mansing, very good. Okay, yeah, definitely. Okay, Yong Eun, A and D. A and B. Strange. Use this. Okay. Why so funny? Okay. Junyuan B. How come you know the arrow but you don't know the pointer? It's A and C, Junkit. Okay, common. A and C is a very common. Xiaoyong A and C, yeah, A and C is the most common. That's what I expected because in ARM, in ARM only in memory usage, you always use the arrow product. Okay. A and C also. How about others? Or they already left the group, go to toilet, sleeping, or just leave the video on only. Okay. Let's call someone. Let's pick someone. Okay. Let's pick someone. Law Kai Chin, where are you? Kai Chin? Which one? A, B, C, D? Kai Chin is not in. Law Kai Chin is not in. He's already very tired. Went to the bed. Okay. Which one? A, B, C, D? I just go to the toilet for a while. Next time go to the toilet, raise your hand, so that I can stop for a while. Then you miss the very important moment, like watching movie. Now it's like watching movie, in the movie hall, 2 hours movie hall. When you watch this Lord of the Ring, you cannot just go to the toilet, just pause it, correct? Okay, Nicholas. Nicholas is not here at all. Where is Nicholas? Okay, yes, A, B, C. A. Okay. Yu Chunmin. Yu Chunmin absent. No Yu Chunmin. I can't see Yu Chunmin in action also. Oh, okay. You are here. Are you sure? Are you okay? So far, so good. Okay, everything okay? You think so? Okay, let's get another one. Cheng Teng Hui. Cheng Teng Hui is not here. Who is Cheng Teng Hui? Okay. Yeah, okay. Next time I call and then just switch on your video I want to see your face. I don't even know who is Cheng Teng Hui. My God. Okay, let's move on. Okay, so class, so this is something that is always happening. Okay, a conventional one, you type your ASM, those there when you're learning PIC 18, you type your assembly code. You assembly code the assembler, you compile, you generate the hex code for you, and you can have a list file, and then there's a symbol file. The symbol table will tell you how many memory you use up, for the program code, how many memory you use up for the data code. Okay. Same if you have got C compiler here, you just compile, go to machine code and linker, you can get all the file that you want. Okay. So normally when you come to MPLAB, okay, MPLAB, the compiler will generate the assembly code for you, and then you can create the hex code and that object file for you. So this is the process, to create the executable file and create a hex code that go into your microcontroller. Okay, what is this? Okay, this now. Okay, so this one no problem lah. So all of you know this. They know the why big microchip hex code is so important. So, and class, remember there's homework, but okay, I thought today I can finish pick 24. Unfortunately, no, there are a lot of complication. Just pick 18 only with a simple Proteus took us about 3 hours, more than 3 hours. But never mind. So next week when I start pick 24, you notice that the hex code is a bit different. So I want you, to no need to explain already. I already told you the answer. I want you to analyze the pick 24 hex code. Okay, compare to the disassembly list. Still remember, hex code is still the same. You still got all these funny dot colon. Okay, so you still remember today you got pick 18. You compare with the list file, is perfectly matched, all right. So next week, pick 24. You got your hex code. You check with the list file, is it matched? Okay. So why is it important? Because you need to understand how the hex code is functioning so that you can write the firmware, for the picket 3 or picket 4. Okay. So here are the things that is coming up, in the microchip. C code, assembly code, linker, and hex code. COF file is generated, is a debug for debugging to your Proteus, and memory map file, how many memory is being used. Okay, so linker is linked with other C file. Okay, so class, do you know that when you download the XC compiler, do you see that there's one option to give you a key for optimization, give you a 60 days, all these things. Do you notice that? Do you click the 60 days? It's 360 days. Do you know that it's very expensive? It's cost about 900 US dollar, for the optimization capability. So what is optimization? Example, I compile I equal to I plus j. If without optimization, without no optimization here, no optimization, you see the code, move the register to j, add I, move again, add again. You see or not? It's additional one line of code. But you perform optimization, it cuts short one line. So imagine if you got a lot of mathematics, your code is C programming code is a bit tedious, more code will be generated. So it's not optimized, the code. If the code is not optimized, you tend to slow down, the performance of the microcontroller. So that's the reason when you buy the XC6 or XC16 with the optimization capability, it is quite pricey, it's quite expensive. Okay, so one-time cost is about 800 US dollar. Okay, you buy separately, XC8 example is about 500 US dollar for each. Okay, so it's not cheap. Okay, but for student, you don't care. Why you so care about this? Your senior say, oh, I want to find the special edition in what torrent file download it the special. I say, what's the point? Okay, you're not doing big business. Okay, so without optimization is perfectly all right for student. Okay, so but if you want to think that you're very good, very great, you want to find a special version, go ahead. I'm not going to stop you. Okay. But of course, sometimes at the end, when you compile the code, your friends compile your friend without optimization is 10K. You with optimization is 2K. Then you're so happy. Okay, just that only. You feel happier because you got money to buy the optimization version, okay? Okay, good, but money, okay? So remember one thing, okay? C is not as portable between architecture and compiler, as everyone claims. What does it mean? So I write my C program in microchip. I cannot just copy and paste and run it in AT89S8252 microcontroller, which is not microchip. Okay, so C is not portable between architecture, but however, the NCC language is portable. Like what? Like if X greater than 0, X plus plus. So you can copy and paste, it's no problem. The concept is the same. So this means that if you master C programming, the fundamental concept is definitely not a problem for you to migrate to Java, to Visual Basic, to C Sharp, you know, to Python. You know, if you master C programming, you move to Python. It's just that easy as ABC. Okay, because C is much tougher than Python, so it's perfectly all right. Okay, so remember the processor specific library is not portable. You cannot migrate the processor, correct? Like today using PIC18, tomorrow I'm using PIC24. I cannot migrate my PIC18 to PIC24. Am I right? Okay, no, okay. Even migrate between processor also cannot. So processor like interrupt all these things, no. You see, like PIC18 got 4 ports, PIC24 might be got 2 ports only, so some port cannot be migrated. Okay, and remember, C is not as efficient as assembly code. C programming, if you're very good in assembly, very good, I mean very good, better than the compiler. Okay, so you are better than the machine example. So still, you are better than C. Okay, but however, not many human, not many of you able to do this. I didn't say no. Okay, I myself cannot. I think C compiler is better than me. Okay, with optimization. Okay, so remember, a good assembly programmer can usually do better than the compiler, no matter what the optimization level. This is what, not I say, this is according to a lot of programmers. They say, they come out with this conclusion. If you're a good assembly writer, better write everything in assembly. But I'm not going to write 1,000 lines long. Instead, in C, I just have 100 lines times 10 normally. Okay, so and C also use more memory. It is definitely because C use more memory. Okay, and there's no such thing self-documenting. There's no such thing in this world, whether Python or anything that can have self-documenting. You type one code, they're self-documented for you. Okay, what is the function of this code? If you got this, PM me. I will definitely buy from you. Okay, there's no such thing like self-documenting. And remember, documentation is very important, but not every line. You know, your senior want to get more marks. Every line they comment. For what? Okay, so something that you tend to forget in future, you put a comment down there. Okay. So because of many shortcuts available, C is not as friendly as to new user. Yeah, it's true. So so that's why you need a command, you know, for appropriate place. Okay. So okay, configuration register. I think we stop here. I think all of you are tired already. I also quite tired because today is quite a number of hours. So we have 10 more minutes left. Is for you to ask questions, and I look through your questions. Okay. So we stop at the configuration register. And class, one more thing. This chapter is, I can say that it's a very boring chapter. It's about 170 pages. Okay, so, and remember, each section they got a lab. This lab is only for those who are not familiar with C. Okay, you look at here, they got lab 1. So all this lab, I already create 12 labs, 12 exercise for you to try at home. Okay, it's already with you, it's over here. lecture 2 companion DC. Okay. They got 12 lab over here, 18 lab over here. The answer also inside. There's the answer. The answer is already with you. There's a solution. Okay, it comes with the solution. All the lab questions is in our lecture 2. This slide. That's the reason they got so many of it. And remember, I'm not going through all this lab. You have to try at home. If you are the newbie, you just try at home. Okay. When I'm writing this lab, actually is still at the very old version of MP lab. You know, it's still version 7.51. It's perfectly all right. You can import the lab. Okay, example. You know, let's say I'm open MP lab X over here, just to let you have a look. Class, you only try this lab when you feel that you are not confident, okay, or some section you're not confident. For example, I move until pointer, you want to try the pointer lab, then you just go and get just click in, you know, to try it and compile it, you know, based on the question given in my lecture 2. Let's say, for example, I can open, you know, I can import the MP lab version 8 project. I click this, okay, browse. I go to my desktop, lecture June. I cannot. Lecture 2 companion C. Let's look at lab 0. Just click this MCP, open. All the code I already typed written for you. You just need to compile and see. See, you automatically, you know, just click simulator. Next, 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 next. Finish. I'm using GA128 source. This is the code log. This is the code log. It's written in so long already. My God, I've been here so many years. In June 2011. Wow, 9 years. I can't remember also. Anyway, so here are the things. Okay, you can printf. Okay, you run it. Okay, when using printf, you need to enable this simulator UART. Enable this. Okay, enable this. Okay, enable this. UART. Okay, enable this. Okay. Then you can see the output. When you run it, you compile, you can see the output. Okay. Is it all right? Okay, it's recorded. You can replay this later. Okay. Again, you know, this lecture is for 174 pages. It's quite boring because it's all on C programming. Okay, things become interesting only when you come to the come towards the end. We have another new note. Okay, we start some of the ESP32. It's still using a bit of C kind of language lah. So it's Arduino language for ESP32. Towards the end, you know, to let you try some of the language. It's very straightforward, very easy, you know, in Python language. Okay, so here are some of the things that you go through lah. Okay, so any other questions? Any other questions? Okay, in order to make this this chapter interesting, I will keep switching, you know, to MPLAB IDE to demo some of the output lah, to see, you know, how the effect, you know, when you compile that particular code. Like for example, you know, there's some very interesting things here, like what is the difference between extern? What is extern means? Okay, what is so unique about attribute? What is constant? You know, what is a how it affect your C programming when using constant. So I will try to use it. And then what is a auto PSV? All this thing is a very unique language, okay, that you can use in microchip, okay. Okay, and then in line with this XC16 user guide, I hope that you already have all the user guide. Okay, so sometimes you don't know how to write some language, in C. Actually, they got user guide for you. It's over here. XC16 user guide. This is a XC8 class. Start from next week. I'm not going to use XC8 anymore. We fully concentrate on XC16. Okay, here are the XC16. Okay, not this one. Okay, XC16. They got about 399 pages. Of course, you're not going to read, until 399 pages. Let's say, for example, I don't know how to write interrupt in PIC24. Just search. Search from here. Okay, interrupt function is just click. Okay, okay, how to write interrupt, low priority, okay, I can just copy and paste this, and write, as how to write an interrupt correctly in microchip. Okay, is it all right? Okay, so any other questions? I hope I'm not feeding you too many things today. From the lab 2 hours and the lectures 2 hours, very stressed. Okay, so any questions? Any questions? Just 33, still got 2 absent. I think they're already scared of this, frightened by me. Okay, probably they have dropped the subject because we got add and drop within these 2 weeks now. Okay, any questions? Swimming in Indian Ocean. Okay, congratulations. We can build a picket tree to use. Yes, I got a whole schematic diagram. Kai Chin, actually in 201314, your senior is building their own picket because Utah don't want to purchase a picket at that time. Okay. Okay. If you're interested, I still got a lot of PCB board, picket tree PCB board. You just need to drill a hole and buy the components. I got everything. Okay. Of course, they got some minor problem with the power because when I design it, I make a bit of mistake, but that's a small problem. Okay. If you're interested, I can pass everything to you, even the PCB board. Even though I got the hardware PCB board I already built, you just need to drill the hole. Okay, everything is there already. I think it's already etched by the lab assistant at that time. Why you want to build picket tree? For fun, okay? Okay, because Utah already got picket tree. Okay, and class, one more thing. Those of you in Klang Valley, if you don't want to buy, you say you're very poor, you are not afford to buy ESP32, even though it's just 20 over ringgit only. So you can always fill up the form. I will post the form to our FB group. You can fill out a form and email to the appropriate lab assistant, and then he gives you a time. You can go back and launch those equipment, okay, like multimeter, like ESP32, LED, all these things you can launch from Utah But those who are outside Klang Valley, because the delivery fee is not cheap so I don't think so. They will send it to you. Okay, is it okay, class? Have you so we can build and sell to micro P student? Hey, my dear, when I build that, it costs about 20 ringgit. You buy the private version from Citron, student also get about that price. So why they want to buy from you, Nicholas? So any other questions? Background R18 thing cannot show face. What is that? Kai Chin, I don't understand what is this. No webcam, how? Hey, Nicholas, you can using your phone download the Microsoft Teams into your Android phone. What's the problem showing your face? All right or not? Okay, ask someone to open. That's the one who's swimming in the ocean. Lim Yichuan, switch on your cam. You see? Don't dare to switch on your cam. Anyone dare to switch on your cam? Any more questions? If no questions, then so how have you get your ESP32? Okay, Flutter. Okay, good. Okay, no questions. Okay, I think it's a quite tiring today. Any other questions? Better switch on my cam. Yeah, any other questions? Any questions? If no, I think that's all. So I also feel a bit tired already. I want to go for jogging. Okay, take a good care and enjoy. Have a good weekend, and then I will catch up with some of you, tomorrow for the integrated product design. Okay, see you. Bye bye.